Hello, this presentation is BioArt, the integrating of the arts into STEM, creating STEAM. My name is Brad Chandler, and along with my colleague Alba De Leon, we're both professors at Palo Alto College in San Antonio, Texas. Traditionally, the arts and the sciences in at least Central Texas have had limited interaction with each other. Very few arts included the sciences, and very few sciences have included the field of art. We found that our art students are highly intelligent, they're creative, they're curious, but they lack the confidence to participate and excel in the life and physical sciences. Conversely, our science students are also highly intelligent and curious, but they tend to only dabble in the creative arts and they use it as a pastime. Both students, groups of students, have to take the opposite field. Biology students have to take an art class, and art students have to take science classes in order to meet core course requirements for the state of Texas. The movement to prioritize STEM in higher education, at least in Central Texas, South Texas, goes back about 15 years or so. Unfortunately, due to campus design, the art students, studios, and classrooms, and the STEM centers, the locations for the life and physical sciences, have typically been located on opposite sides of campus, which have limited the interaction between the two groups of students. However, with advances in technology and the rise of interdisciplinary studies, the need for science majors who understand the arts and art majors who understand the sciences has increased over time. A couple of examples of that include dental laboratory technicians. We have a couple of centers in San Antonio that hire art students to come in and create realistic false teeth, artificial teeth. It'd be too easy for the firm to create standard molds of teeth that look like, quite literally, pieces of plastic that could be pulled off of a shelf. And so the art student's job is to use their knowledge of the arts combined with their understanding of the sciences to create realistic teeth that are non-perfect and look like the real thing. The opposite of that would be medical illustrators. These students tend to be science majors who have a firm grasp in the biological or the physical sciences, and they create drawings for our textbooks, for web sites that support the textbooks, that combine color and depth, accuracy, and the ability to label and explain what's going on in these complex life and physical illustrations. In the spring of 2019, we began a BioArt project that was designed to introduce art students to the microbiology lab and biology students to the visual arts lab and class studios. We produced a laboratory guide which combined microbiology lab techniques with art terminology and studio practices and designed it to be basically at a layman's level that anybody could pick up and understand both what they're doing and how to be safe and the techniques involved. Implementation began in the fall of 2019. It continued through spring of 2020 until the COVID virus forced us away from campus. We had 2 art cohorts of students and 1 biology cohort of students who participated in painting petri dishes with colored bacteria. We used 6 different colors of bacteria, from white, yellow, pink, red, purple, and fluorescent bacteria. And when they painted the bacteria, sometimes the mother colonies were not colored because they're stock colonies coming from the biological supply companies, and they haven't developed their colors yet. So they're painting with invisible paint. Sometimes the bacteria did already have color. They would make these two-dimensional pictures, if you will. We would incubate them for 5 to 11 days and take pictures of them in different steps of the development of the growth of the bacteria, and as the different colors came out under different temperature regimes and lighting conditions. And so here are some of the typical representative petri dishes that were grown on nutrient agar, on blood agar. We had some fluorescent bacteria at the bottom and the middle that produced interesting combinations of light and color and media to our students. After each cohort had gone through the process, because we had a teaching process. They didn't just come in and pick up a wand and start painting the first day. They had to go through several steps in order to do this, in order to learn the proper way to do this and be safe about it. And then they got to see the results. And then we designed surveys which were implemented to gauge the student satisfaction with the project. Their interest in the opposite field. If they were art students, did they enjoy the biological side? If they were biology students, did they enjoy doing something with bacteria that they might be working with anyway, but in a creative way? Unfortunately, we didn't have enough students for these 10-question surveys to have a statistical significance in any one area, but in general, most of our students enjoy the project for different reasons. The art students enjoyed learning a new material and could envision new directions to go with this in the future if they could pursue it. And the biology students who were used to mundane tasks and the regimens of science were allowed to express their creative side, and they enjoy the project that way. We hope to have more data in the future in order to have solid statistics that we can share in a future presentation. It went very well. I want to thank you for your time and your interest in our little project. We have several people we'd like to thank. It includes Dr. Lance Sandberg, Sarah Wilkins, Flavia Aguilar, our Dean Patrick Lee, and all the students in our classes that elected to do this on their own time and participate in this project and follow up with the surveys and get a little bit out of their comfort zone. Thank you.